News with no bias. Expose. News with no exemption. Expose. Delivering nothing but the truth. Live from the tuna capital of the Philippines, this is 99.9 DXYZ The Expose. Your news, our business. Good morning, Philippines. Good morning, General Santos. It's a wonderful day, August 18, 2021. This is John Mark Bedayo.
This is Imee Pot.
And this is Cydilyn Lovitos,
Bringing you the hottest and latest news of the hour. 99.9 DXYZ The Expose. Your news, our business. For the headlines. For international news.
PERT CPM, useful tool for complex projects.
For national news. PERT Cost, helpful tool for managers focusing on costs. For the local news.
Project Crushing, a key for meeting project deadlines.
Time check. It's 8:03 in the morning. This time check is brought to you by SM Supermalls. Here at SM, we got it all for you.
Here at SM, we got it all for you.
For the international news, PERT CPM, useful tool for complex projects. We have Imee Pat for the update. Take it away, Imee.
Thank you, JM. As every industry operates their day-to-day operations or activities based on the plans they've set out in achieving their objectives, either short-term or long-term, lahat tayo, even if we're not in the business setting, thus activities depende sa mga plano natin sa buhay. Gaya na lang na kagustuhan nating makapagtapos ng pag-aaral, maging CPA, magkabahay, or etc. Para ma-achieve yun, may mga steps tayong kailangan gawin ng sunod-sunod. As simple as it seems, as we look at the business world, or at the business perspective, projects or planned undertaking vary in its simplicity, size, and duration. They can be simple. Just like kung gusto mong magpa-party sa inyo, may ilang preparations kang dapat gawin. Or it could be complex, like as the textbook provided, launching a space shuttle. As big companies of almost all industries often have series of complicated, large-scale projects, they often worry about its management. So paano nga ba ito mamamanage? Dito papasok ang role ng PERT or the Project Evaluation and Review Technique at CPM or the Critical Path Method. Utilizing this technique will provide a graphical display of project activities that helps the users understand the relationships among those activities. And also, it also prioritizes the most crucial tasks to keep projects in line and on time. So, PERT and the CPM is a quantitative analysis techniques that help managers plan, schedule, monitor, and control large and complex projects. So, as you can see, it is stated that PERT is probabilistic, since its activities use 3 time estimates which are then combined to determine expected activity completion time. So, itong estimates are the pessimistic, optimistic, and most likely time that are determined by the project managers, which will be discussed later. Next is CPM. CPM is considered as deterministic. So why? CPM is considered deterministic since it is assumed that the times are known with certainty. So if you are a manager at gusto mong gamitin ang technique na ito, you're gonna have to follow these 6 steps. which are the following. So first, we are to define the project and all of its significant activities or tasks. Second is to develop the relationships among the activities and also decide which activities must precede the other. Third is to draw the network connecting all of the activities. Next is to assign time and or cost estimates to each activity. Compute the longest time path through the network, which is called the critical path. And lastly, we are to use the network to help us project managers plan, schedule, monitor, and control the project. So to provide you with a more practical view of this technique, we have this example of the project to be made by the General Foundry INC. So, General Foundry INC is a metalworks plant in Milwaukee, has long been trying to avoid the expense of installing air pollution control equipment. The local environmental protection group has recently given the foundry 16 weeks to install a complex air filter system on its main smokestack. General Foundry was warned that it will be forced to close unless the device is installed in the allotted period. So Lester Harkey, the managing partner, wants to make sure that the installation of the filtering system progresses smoothly and on time. When the project begins, the building of the internal components for the device, which is the activity A, and the modifications that are necessary for the floor and roof, activity B, can be started. The construction of the collection stock, which is our activity C, can begin once the internal components are completed, and pouring of the new concrete floor and installation of the frame, or activity D, can be completed as soon as the roof and floor has been modified. After the collection stock have been constructed, the high temperature burner can be built, which is our activity E, and the installation of the population control system, or activity F, can begin. The air pollution device can be installed, activity G, after high temperature burner has been built. The concrete floor has been poured and the frame has been installed. Finally, after the control system and pollution device have been installed, the system can be inspected and tested, which is our activity A. So galing sa case na ito, makikita mo na may mga series of activities na kailangan i-undertake ng General Foundry INC. Kaya ng mga sinabi ko kanina, we have activities from A to H. So, since may deadline sila na kailangang sundin, napaka-crucial ng planning at time scheduling ng bawat activity. Kaya gagamitan natin ito ng PERT or CPM na mga techniques. So, unang-una, kung naaalala nyo pa, ay may 6 steps tayo na dapat sundin. So, first we have to define the project and all of its significant activities or tasks. So, basically, andun na lahat sa cases na yun. All you have to do is to make a table for it to be more comprehensive at mas madali mong maaalala kung ano yung mga activity na andun. After natin magawa ito, ay titingnan naman natin kung anong activity ang dependent sa completion ng naunang activity. So, we have step 2, which is to develop the relationships among the activities and to decide which activities must precede others. So, based sa case ng General Foundry, we have A and B can start right away since wala silang predecessors. C can start after the completion of activity A. D naman will start pagkatapos ng activity B. E and F starts by the time C is completed. G starts after activity D and E. And lastly, si H naman will start after F and G. Since na-lay down na natin ang mga activities with predecessors sa ating table, the next step is to draw the network connecting all of the activities. So we have there the start and the finish. This way, you can clearly see the activities that are dependent of each other. Pagkatapos mo itong gawin, we are down to step 4, which is to assign time and or cost estimates to each activity. It is now the time that project managers will use probability distribution using 3 time estimates to assign our activity times. So, These are the 3 time estimates that they will be using. First is we have the optimistic time, which is the time an activity will take if everything goes as well as possible. There should only be a small probability, says 1 over 100 of this occurring. Next is we have the pessimistic time, which is the time an activity would take assuming very unfavorable condition. There should only be a small probability that the activity will really take this long. And lastly, we have the most likely time, which is the most realistic time estimate to complete the activity. So, after that, they will be using a weighted average of these times that will be used to find the critical path later on. So, to find the expected activity time, the beta distribution weights these estimates as follows. So, that will be T equals to A plus 4M plus B over 6. So, next is to compute the dispersion or variance of activity completion time, and we will be using this formula. Variance is equals to B minus A over 6 squared. It is already laid down here in the PPT. So, the project managers have already given us the 3 time estimates based on historical data. What we need to do is to solve for the expected time and the variance. So, as you can see in the table, all you need to do is to substitute these values. So, for activity A, we have our expected time 2, B 3, C is we have 2 weeks, D we have 4 weeks, E we have 4 weeks, F we have 3 weeks, G we have 5 weeks, H we have 2 weeks. So overall, we have 25 weeks expected time. So variance is also there. All you need to do is to substitute. We will gonna be using this variance for solving the probability of project completion later on. The next step is the computation of the longest time path through the network, which is called the critical path. So to find the critical path, we need to determine the following quantities for each activity in the network. So first we have the earliest start time, which is the ES, the earliest time an activity can begin without violation of immediate predecessor requirements. Second is the earliest finish time, which is the EF, the earliest time at which an activity can end. Third is the latest start time, the latest time an activity can begin without delaying the entire project. Lastly is we have the latest finish time, LF, the latest time an activity can end without delaying the entire project. So below there is the figure which represents the nodes figures of our network. On the upper left is the activity, following is the T representing the activity time. Down the activity is the ES or the earliest start time. Beside it is the earliest finish time. And on the lower left is the latest start, and following it is the latest time. So in finding the critical path, we first show how to determine the earliest time, which is a process called the forward pass. So there are 2 basic rules to follow when computing earliest time start and earliest finish time. The first rule is for the earliest finish time, which is computed as follow. Earliest finish time equals to earliest start time plus the expected activity time. Also, before any activity can be started, all of its predecessor activities must be completed. In other words, we search for the earliest finish time for all of the immediate predecessors in determining earliest start time. The second rule is for the earliest start time, which is computed as follows. Earliest start is equals to the largest of the earliest finish times of immediate predecessors. So, in this network, A has no predecessor, so its earliest start time will be 0 or right away. Since it has 2 weeks to be completed, its earliest finish time will be 2, which gives us 2. B has also an earliest start time of 0 and activity time of 3. It will have an earliest finish time of 3. Now, C needs A to be completed before it can start. Since the earliest finish time for A is 2, then the earliest time C can start is 2. And with an activity time of 2 weeks, C will have an earliest finish time of 2 plus 2, which is 4. D also needs B to be completed before it can start. Since the earliest finish time for B is 3, then the earliest time D can start is 3. And with an activity time of 4 weeks, D will have an earliest finish time of 3 plus 4, which is 7. Activity E also starts by the time C is completed. Its earliest start time is 4, since earliest finish time of C is 4. Activity time 4 plus earliest start time 4 will give us 8 weeks earliest finished for E. So F also needs C to be completed before it can start. Since the earliest finished time for C is 4, then the earliest time F can start is 4. And with an activity time of 3 weeks, F will have an earliest finish time of 3 plus 4, which is 7. G, on the other hand, needs D and E to finish before it can start. Since yung earliest finish time ng D at E ay 7 at 8, at kailangan matapos ang mga ito bago magsimula ang G, then ang earliest start time ng E is 8. Meaning, kung ano ang highest earliest finish ng preceding activity, yun yung earliest start time ng G. So, activity G finishes at 8 plus 5, so that is 13. Si activity H naman also needs activity F and G to finish before it can start. So, gaya kanina, kung ano yung highest earliest finish time sa dalawa, yun yung earliest start time ng activity H, which is F is 7 and G is 13. So, yung earliest start time ng H is 13. Its earliest finish time is 2 plus 13, which give us 15. So, we say that the project's completion time is 15 weeks. After we did the forward pass, we are now going to do the backward pass. So, the next step in finding the critical path is to compute the latest start time and the latest finish time for each activity. We do this by making a backward pass, as I said, through the network that is starting at the finish and working backward. There are 2 basic rules to follow when computing the latest times. The first rule involves the latest start time, which is computed as latest start time equals to latest finish time less activity time. Also, since all immediate predecessor must be finished before an activity can begin, the latest start time for an activity determines the latest finish time for its immediate predecessors. If an activity is the immediate predecessors for 2 or more activities, it must be finished so that all the following activities can begin by their latest start times. Thus, the second rule involves the latest finish time, which is computed as latest finish time equals to the smallest of latest start time for following activities. So, since our project completion time is 15 weeks, the latest finish time of H is 15. Next is we obtain the latest start times by subtracting the activity times from the latest finish. Thus, 15 minus 2 will give us 13. G will have the latest finish time of 13 since the latest start time of H is 13. Para makompute ang latest start time, that is 13 minus 5, so we have 8. F also have the latest finish time of 13. So 13 minus 3, we have 10 as its latest start time. Since G's latest start time is 8, yung latest finish time ng E is 8. Then yung latest start time niya is 8 minus 4, so we have 4 weeks. D also have a latest finish time of 8 since G's earliest start time is 8. Its latest finish time is 8 minus 4. We have again 4 weeks. Now, C has two successors, E and F. Their latest start times are 4 and 10 respectively. As a result, the latest time C has to finish has to be 4 in order for E to start. In essence, when doing backward pass, the latest finish time of an activity must be the lowest or minimum of the latest start times of its successors. Kung kanina highest kinuha natin dito sa backward pass, we are to take the minimum time. Thus, the latest start time for C will be 4 minus 2 is 2 weeks. For B, same as the others, the latest start time is 4, thus its latest finish time is 4. So 4 minus 3, the latest start time of B is 1. Lastly, since again, there is no two or more successors, A will just use the latest start time of C, which is 2, as our latest finish time. So 2 latest finish time less 2 activity time, we have 0 as our A's latest start time. So, after natin ma-determine yung earliest start, earliest finished, and latest finished, it is a simple matter to find the amount of slack time or free time that each activity has. So, this slack time is the free time for an activity. It is the length of time an activity can be delayed without delaying the whole project. So, mathematically, slack is equals to latest start time less earliest start time, or slack time is equals to latest finish time less earliest finish time. So, the table there summarizes the ES, EF, LS, LF, and slack times for all of the general foundry activities. So, for example, for activity B, it has 1 week of slack time since latest start time 1 is less earliest start time of 0, which is 1, or pag ginamit naman ninyo yung latest finish time less earliest finish time, same pa rin ang lalabas, which is 1 week. So this means that it can be delayed up to 1 week without causing the project to run any longer than expected. So on the other hand, activities A, C, E, G, and H have no slack time. This means that none of them can be delayed without delaying the entire project. So because of this, they are called critical activities and are said to be on the critical path. So next is we have the determination of the probability of project completion. The critical path analysis help us determine that the foundry's expected project completion time is 15 weeks. Harkin knows, however, that if the project is not completed in 16 weeks, General Foundry will be forced to close by environmental controllers. He is also aware that there is significant variation in the time estimates for several activities. So the variation in activities that are on the critical path can affect overall project completion or possibly delaying it. This is one occurrence that worries Harky considerably. So, PERT uses the variance of critical path activities to help determine the variance of the overall project. If the activity times are statistically independent, the project variance is computed by summing the variance of the critical activities. So as you can see, the first thing we need to do is to compute the project variance, which is the summation of the variances of activities on the critical path. As you, if ma-remember nyo pa, we have already solved this on our step 2. So, ayan, project variance, 4 over 36 plus 4 over 36 plus 36 over 36 plus 64 over 36 plus 4 over 36. We have 112 over 36, or the 3.111. So the next step we are to do is to compute the standard deviation. So we know that the standard deviation is just the square root of the variance. So the project standard deviation is the square root of 3.11. So that is the 1.76 weeks. So for Harky to find the probability that this project will be finished on or before the 16-week deadline, the standard normal equation can be applied as follows. So we have z is equals to due date less expected date of completion over the project variance. So that is 16 weeks less 15 weeks over 1.76 weeks. We have 0.57. So referring to the normal table, we find a probability of 0.71566. Thus, there is a 71.6% chance that the pollution control equipment can be put in place in 16 weeks or less. The sixth and final step is to monitor and control the project using the information provided by PERT. So, after we did all of those steps, this is what PERT was able to provide. So, PERT has thus far been able to provide Lister Harky with several valuable pieces of management information. So first, the project expected completion date is 15 weeks. We have determined that using the critical path analysis. Second, there is 71.6% chance that the equipment will be in place within 16-week deadline. PERT can easily find the probability of finishing by any date Harky is interested in. Third is 5 activities, namely A, C, E, G, and H are on the critical path. And if any one of them is delayed for any reason, the entire project will be delayed. On the other hand, 3 activities, namely B, D, and F are not critical, but have some slack time built in. This means that Harky can borrow from the resources if needed, possibly to speed up the entire project. And lastly, PERT was able to provide a detailed schedule of activity starting and ending dates has been made available. So for more updates, we have Cydilyn Lovitos. Cydi?
So ang example natin kanina can be worked using the program ExcelQM. To do this, iselect natin ang ExcelQM. Then, click ang by chapter to see the models list. Put the cursor over the project management at may lalabas na choices. To input a problem that is presented in a table with the immediate predecessors and the use of 3-time estimates, select natin ang predecessor list AON. And an initialization window will appear. So, ilagyan na natin ang title. Then, enter natin ang number of activities, which is 8. Then, ang maximum number of predecessor, 2. And select natin ang 3-time estimate option. Kung gusto natin lagyan ng Gantt chart, i-check natin ang Gantt chart. Click OK. Then, may lalabas na spreadsheet with all necessary rows and columns labeled. Pagkatapos, i-enter natin ang mga given values kanina ng 3-time estimate and the immediate predecessor. So, pagkatapos natin na input ang data, so ito na, makikita natin ang table with all the earliest, latest, and slack time. Also, makikita rin natin ang project variance na 3.11 and ang standard deviation na 1.76. So also a Gantt chart that shows the critical path and the slack for the non-critical activities. So with this, pinapadali ni ExcelQM ang trabaho. I-input lang natin ng ating mga values, then automatically kinakalculate na ng program upang makuha ang mga results na kinakailangan.
You're still listening to 99.9 DXYZ The Expose. Your news, our business. Time check. It's still morning. Just check your clock. This time check is brought to you by Saint Peter. Inyong pagkamatay, aming ikinabubuhay.
For the national news. PERT Cost, helpful tool for managers focusing on cost. We have John Mark Bedayo for these news. JM?
Before we introduce to you the PERT cost, we will share to you the sensitivity analysis. So during any project, the time required to complete an activity can vary from the projected or expected time. If the activity is on the critical path, the total project completion time will change. In addition to having an impact on the total project completion time, there's also an impact on the earliest start, earliest finish, latest start, latest finish, and slack times for other activities. The exact impact depends on the relationship between the various activities. So, here comes the sensitivity analysis. So, sensitivity analysis is a financial model that determines how target variables are affected based on the changes in other variables known as input variables. This model is also referred to as what-if or simulation analysis. It is a way to predict the outcome of a decision given a certain range of variables. So at this point of time, we will dig into the PERT cost. Although PERT is an excellent method of monitoring and controlling project length, it does not consider another very important factor, which is the project cost. PERT cost is a modification of PERT that allows a manager to plan, schedule, monitor, and control cost as well as time. We begin the section by investigating how cost can be planned and scheduled. Then, we see how cost can be monitored and controlled. Planning and scheduling project cost. The budgeting process. The overall approach in the budgeting process of a project is to determine how much is to be spent every week or month. This is accomplished as follows. So we have here the 4 steps of the budgeting process. First is identify. We should identify all costs associated with each of the activities. Then add these costs together to get one estimated cost or budget for each activity. The second one is combine. If you are dealing with a large project, several activities can be combined into larger work packages. A work package is simply a logical collection of activities. Since the General Foundry project we have seen discussing is small, one activity will be a work package. The third one is convert. Convert the budgeted cost per activity into a cost per time period. To do this, we assume that the cost of completing any activity is spent at a uniform rate over time. Thus, if the budgeted cost for a given activity is $48,000 and the activity's expected time is 4 weeks, the budgeted cost per week is $12,000. 12,000 divided by 4 weeks. The last or the fourth one is find. Using the earliest and latest start times, find out how much money should be spent during each week or month to finish the project by the date desired. Let us now apply this budgeting process to the General Foundry problem. To develop a budget schedule, we will determine how much will be spent on each activity during each week and fill these amounts into the charts in place of the bars. Lester Harkey has carefully computed the cost associated with each of his 8 activities. He has also divided the total budget for each activity by the activity's expected completion time to determine the weekly budget for the week. The budget for activity A, for example, is $22,000. Since its expected time is 2 weeks, $11,000 is spent each week to complete the activity. So looking at the total of the budgeted activity cost, we can see that the entire project will cost $308,000. Finding the weekly budget will help Harkey determine how the project is progressing on a week-to-week basis. The weekly budget for the project is developed from the data. The earliest time for activity A, for example, is 0 because A takes 2 weeks to complete. Its weekly budget of $11,000 should be spent in weeks 1 and 2. For activity B, the earliest start time is 0. The expected completion time is 3 weeks, and the budgeted cost per week is $10,000. Thus, $10,000 should be spent for activity B in each of weeks 1, 2, and 3. So, using the earliest start time, we can find the exact weeks during which the budget for each activity should be spent. These weekly amounts can be summed for all activities to arrive at the week's budget for the entire project. So as you can see here, we provided you the Gantt chart for the General Foundry example. So this Gantt chart shows when the activity should start and when does the activity finish. And now, we will show you the budgeted cost for General Foundry Incorporated using the earliest start times. So, the only two activities that can be performed during the first week are activities A and B because their earliest start times are 0. Thus, during the first week, a total of $21,000 should be spent. Because activities A and B are still being performed in the second week, a total of $21,000 should be also spent during that period. The earliest start time for activity C is at the end of week 2. Thus, $13,000 is spent on activity C in both weeks 3 and 4. Because activity B is also being performed during week 3, the total budget in week 3 is $23,000. Similar computations are done for all activities to determine the total budget for the entire project for each week. Then, these weekly totals can be added to determine the total amount that should be spent to date. Those activities along the critical path must spend their budget at times shown in the table. The activities that are not on the critical path, however, can be started at a later date. This concept is embodied in the latest starting time. Thus, if latest starting times are used, another budget can be obtained. This budget will delay the expenditure of funds until the last possible moment. The procedures for computing the budget when the latest start time is used are the same as when earliest start time is used. The results of new computations will be shown on another table. So this table will show you the latest possible time that funds can be expended and still finish the project on time. So the previously shown table reveals the earliest possible time that funds can be expended. So therefore, a manager can choose any budget that falls between the budgets presented in these two tables. These two tables form feasible budget ranges. At this point, we are showing you a figure that shows the budget using the earliest start times and the budget using the latest start times. So in this figure, it is shown that there is a difference between the budget using the earliest start times and budget using the latest start times. Although there are cash flows and money management advantages to delaying activities until their latest start times, such delays can create problems with finishing the project on schedule. If an activity is not started until its latest start time, there is no slack remaining. Any subsequent delays in this activity will delay the project. For this reason, it may not be desirable to schedule all activities to start at the latest start time. Moving on to our next topic, which is the monitoring and controlling project cost. So the purpose of monitoring and controlling project cost is to ensure that the project is progressing on schedule and that cost overruns are kept to a minimum. The status of the entire project should be checked periodically. So we have here a question. So Lester Harkey wants to know how his air pollution project is going. It is now the 6th week of the 15-week project. Activities A, B, and C have been finished. These activities incurred costs of $20,000, $36,000, and $26,000 respectively. Activity D is only 10% completed, and so far the cost expended has been $6,000. Activity E is 20% completed with an incurred cost of $20,000. And activity F is 20% completed with an incurred cost of $4,000. Activities G and H have not been started. Is the air pollution project on schedule? What is the value of work completed? Are there any cost overruns? So to answer the question, we will show you some formula that will help you to solve the problem. So the value of work completed, or the cost to date for any activity, can be computed as follows. The value of work completed is equal to percentage of work completed multiplied to the total activity budget. And in computing the activity difference is equals to the actual cost less value of work completed. If an activity difference is negative, there is a cost underrun. But if the number is positive, there has been a cost overrun. So this table provides you the information for General Foundry. The second column contains the total budgeted cost, and the third column contains the percent of completion. With this data and actual cost expended for each activity, we can compute the value of work completed and the overruns or underruns for each activity. So, one way to measure the value of work completed is to multiply the total budgeted cost times the percent of completion for each activity. Activity D, for example, has a value of work completed of $4,800, which is $48,000 times 10%. So, to determine the amount of overrun or underrun for any activity, the value of work completed is subtracted from the actual cost. These differences can be added to determine the overrun or underrun for the project. So, as you can see at week 6, there is a $12,000 cost overrun. Furthermore, the value of work completed is only $100,000 and the actual cost of the project to date is $112,000. How do these costs compare with the budgeted cost for week 6? If Harky had decided to use the budget for the earliest start times, we can see that $162 should have been spent. Thus, the project is behind schedule and there are cost overruns. Harky needs to move faster on this project to finish on time, and he must control future costs carefully to try to eliminate the current cost overrun of $12,000. To monitor and control cost, the budgeted amount, the value of work completed, and the actual cost should be computed periodically. This is John Mark Bedayo reporting. Back to you, Imee.
You're still tuning to 99.9 DXYZ, The Exposed, your news, our business.
A big shout out to Miss Laika Giranod and Miss Karen Davila.
Kailan ang birthday mo?
November 21 po.
Oh my God! Liar, birthday ko yon!
Birthday ko,
my
Lord
God!
God!
Birthday mo November 21?
Birthday ko po yun.
99.9 DXYZ The Exposed wants to greet you a very advanced happy birthday on November 21. This greeting is brought to you by Drive Max. Tatagal ka ba? And we are back to serve you our local news. Project crushing, a key for meeting project deadlines. We have Cydilyn Lovitos for the updates. Take it away, Cyd.
When CPM was developed, the possibility of reducing the project completion time was recognized. This process is called crushing. Project crushing is a project management technique based on adding more resources of the initially planned in the project to accelerate the project timing. It is possibly done by using overtime, hiring extra workers, or using extra equipments. However, the cost of the project will usually increase as a result. When crashing a project, it is desirable to do this at least additional cost. Project crashing involves 4 steps. First is to find the normal critical path and identify the critical activities. Second step is to compute the crashing cost per week or the other time period for all activities in the network. Next is to select the activity on the critical path with a small crash cost per week. Crash this activity to the maximum extent possibly for the point at which your desired deadline has been reached. Finally, check to be sure that the critical path you were crashing is still critical. Often, a reduction in activity time along with the critical path causes non-critical path or paths to be more critical. If the critical path is still the longest path through the network, return to the step 3. If not, find the new critical path and return to the step 3. Let's use the General Foundry as example. Suppose that the firm had been given 14 weeks only to install the new pollution control equipment or face a court-ordered shutdown. As you recall, the normal critical path was 15 weeks. What can he do? See that Harky cannot possibly meet the deadline unless he is able to shorten some of the activities. General Foundry's normal and crash times and normal and crash cost are shown in the table. In order to compute the crash cost per week for all of the activities, let's use the following formula. Crash cost per time period is equals to crash cost minus normal cost over normal time minus crash time. After that, select the activity on the critical path with the smallest crash cost per week. So activities A, C, and E are on the critical path and each have a minimum crash cost per week of 1,000. The firm can crash activity A by 1 week to reduce the activity or the project completion time to 14 weeks. The cost is an additional of 1,000. So let's check if the critical path you were crashing is still critical by creating new network with expected activity times, earliest times, and the latest times. At this stage, there are 2 critical paths. The original critical path consists of activities A, C, E, G, and H with 14 weeks of completion. And the new critical path consists of activities B, D, G, and H with the same completion time. Any further crashing must be done to both critical paths. For example, if the firm wants to further reduce the completion time by 2 weeks, both paths should be reduced. This can be done by reducing activity G, which on both critical paths, by 2 weeks for an additional cost of 2,000 per week. The total completion time would be 12 weeks and a total crushing cost of 5,000, 1,000 from activity A and 4,000 for reducing activity G by 2 weeks. For small networks such as this example, it is possible to use the 4-step procedure to find the least cost of reducing the project completion dates. For larger networks, however, this approach is difficult and impractical, and more sophisticated techniques such as linear programming must be employed. Project crashing with linear programming is another approach to find the best project crashing schedule. We illustrate its use on General Foundry's network. We will use the same data. So we begin by defining the decision variables. So here, our decision variables, x is equals to the earliest finish time for an activity, and y is defined as the number of weeks that each activity is crushed. This topic, which is related to linear programming, was discussed by the previous reporters, so we will just give you an overview with this approach. The next step is to determine the objective function. Since the objective is to minimize the cost of crushing the total project time, our LP objective function is this. Note that the cost coefficient were the crush cost per time period. Next is to determine the constraints. Crush constraints are required to ensure that each activity is not crushed more than its maximum allowable time. The maximum for each y variable is the difference between the normal time and crush time. So, these are our crush constraints. Also, let's determine the event constraints. So, these are our event constraints. After adding non-negativity constraints, this LP problem can be solved for the optimal y values. This can be done with QM for Windows or Excel QM. This illustration provides the Excel QM, so this provides the solution to crushing problem using solver in Excel. We have seen how to schedule a project and develop budget schedules. However, there are other things that are important and helpful to a project manager. We now briefly introduce these topics. First is SubProject. A SubProject or a SubProjects are projects that is a part of a larger project. So for extremely large project, an activity may be made of several smaller sub-activities. Each activity might be viewed as a smaller project or a sub-project of the original project. And lastly, software. There are numerous project management software packages in the market for both mainframe computers and personal computers. For example is Microsoft Project. Most of these software will draw PERT charts as well as Gantt charts. They can be used to develop budget schedules, automatically adjust future start times based on the actual start times for prior activities and level of the resource utilization. Companies have paid several hundred thousands for project management software and support because it helps management make better decisions and keep track of things that would otherwise be unmanageable. Thank you, JM. This is Cydilyn Lovitos reporting. Back to you, JM.
And we just reviewed the hottest and the latest news of the hour. And you are still with us at 99.9 DXYZ The Expose. This has been John Mark Bedayo,
Imee Pearl Pot,
And this is Cydilyn Lovitos
signing off.